Hi guys, welcome back to my channel. So in this video we're going again over the addressing modes. So I've already covered these addressing modes in my previous videos, so the link to those videos are in the playlist. You can check out the playlist and find the link to these videos, but in this video we will go ahead and explain the indirect addressing. Okay, so these are the four addressing modes that we covered. Okay, so now moving on to indirect addressing. So indirect addressing basically uses a register to provide a location in the memory. Okay, so if you want an example of the indirect addressing, so that would be something like load R1 and then we have the address of R2. So in the indirect addressing, you're always gonna have like some sort of brackets over here. Okay, so that's how you will distinguish between indirect addressing and like register direct addressing, because here you have brackets which signifies the memory. Okay, so what does this basically mean? So this basically means that you use the memory address in R2 and store the contents in R1. Okay, so I can write it over here. Use memory address in R2 and store the contents in R1. Okay, and if you still don't get it, you can write we can write the equivalent expression in RTL. Okay, so because RTL is easier to understand, right? So R1, and we have this, whatever is it, it's some sort of arrows. Okay, and then we have like memory R2. So this is simple, right? This is basically saying take the memory of R2 and store the contents of that into R1, right? Okay, so if you want a visual representation of what's happening, I can show you that as well. Okay, so here we have this. So what we're doing, we're taking R2 and storing the contents in R1, right? So how it's gonna happen is you have the register R2 over here, right? And you're going to store the contents, place the R2's content into MAR, right? And why are we storing into MAR? Because remember, I explained in my previous videos, you can check out the playlist. The MAR basically we use it to access the address we wanna access, right? Cut. Okay, so this is the visual representation of what's happening when you do this load R1 and then you use the memory address of R2. So the contents of the R2 are stored into the MAR. And why MAR? Like I've explained in the previous videos, you can check out the playlist. MAR basically is used to store the address we want to access. Okay, so it is going to store the address of R2. Okay, and then the memory is going to read that address. Okay, and then the address are going to be stored into MDR. Okay, and MDR is used to place in the memory, like placed in the memory to be written to, or okay, so this is the visual representation of what's happening when you do R2, the memory of R2 and load it into R1. So we basically have the register R2 and the memory address of this one is stored into the MAR. Why MAR? Like I explained in the in my previous videos, you can check out the playlist. So MAR is basically used to store the address you want to access. Okay, so it's going to store the address of R2, and then the address is going to be read into the memory. Okay, and once it's read, it's gonna be the content, it's going to be stored into MDR, because MDR can read and write. Okay, so then the contents of MDR are going to be placed into R1. Okay, so that's what's happening when you do this, right? So R2 going into MDR, MAR, and then MAR after reading the memory, it's storing into MDR, and then from MDR going to R2. Okay, and if this thing is not making sense, don't worry, when we do the bus thing, you will actually know what's happening. Okay, so for now, if you don't understand, it's okay. Okay, so moving on, you have like many types of indirect addressing. One of the example of indirect addressing can be like if you have like load R1 and then you have something like R2 plus 4. So this type of addressing, indirect addressing, is called indirect addressing with an offset. Okay, so this is with an offset. Okay, because we're adding a 4 to the register 2, right? So this basically means load the contents of the specified like of the address specified by R2, and then we're going to add 4 to it. Okay, like adding 4 to the address of it. Okay, so the addition of the R2, R4 and 4 are done, like are placed into the MAR. So the original R2 that you see over here, this is going to remain unchanged. Okay, so like when you add, so it won't affect the R2. Okay, so this addition will be stored into MAR, so the current R2 won't be affected by it. Okay, and then whatever result that you get, you're going to place it into R1. Okay, so this is what's happening. And with the offset, you can have like many cases. So for example, you can have like auto increment. Okay, so an example of auto increment would be load R1 and then you have the address of R2 and then you have a plus afterwards. Okay, so like so you can also call it like post increment. Okay, so what you're basically doing over here is like you're loading the contents of the address of R2, right? And then you're doing the increment. Okay, so like first of all you're loading the contents and then afterwards you're performing the addition. If you want, if this is not making sense, I can go ahead and write it in another way so it's more obvious to you guys. So you know, like you can break down this thing into 2 steps. So like you can say load R1, R2, like so right now you're storing the contents of R2 into the R1, right, the address. So what this basically means, use memory address in R2 and store contents in R1, and then whatever that you get, you're going to add 1 to it. Okay, now next you're adding 1 to R2. So this is what you're basically doing. So just like this, we have another case of auto decrement. Okay, so here we can have like load R1 and then we can have R2, but we have a negative sign over here, which means what we're doing over here, so it's gonna be the same thing that we're doing, right? Okay, I can copy it. Okay, so what we're doing over here, instead of adding, we're basically subtracting. Okay, so like loading the contents of R2 into the R1, right, like using the memory address of R2, the memory address of R2, and storing the contents in the R1, and then afterwards we're going to subtract 1 from the register 2. Okay, so that's what we're doing. And there is also the case of pre-increment. Okay, so we have also pre-increment. So an example of pre-increment would be like load R1 and then we have plus R2. So what does this mean? So this is similar to if we go ahead and do add R2 and then we have a 1. Okay, so we are adding this constant 1 into R2 and then we are loading the address like use the memory address in R2, and then we're storing the contents in R1. Okay, so this is the inverse. Okay, we're adding 1 first to the R2, and afterwards we're storing the memory address, using the memory address of R2 and storing it into R1. Okay, so yeah, this is what we're doing. And then we also have pre-decrement, and of course you already know by now that what it's doing, right? So we have load R1, and then we have a -1 over here. So then what we're doing, we have, so this, oops, so it should be like negative over here. Okay, so this, what is this doing? So this is basically doing subtracting 1 first, right, from the R2, and afterwards we are loading R1, taking the memory address of R2 and loading the contents into the R1. Okay, so this is basically it. If you guys don't understand, so I can write it over here, right? So use memory address of R2 and store contents in R1, and subtract 1 from R2. So this is what we're doing over here, and if you want to know what we're doing over here, so this is basically adding 1. Okay, so I hope it makes sense with the indirect addressing. So see you guys in the next video. Bye.